Today, boys and girls, we're going to look at an awesome new strategy for multiplying big numbers. So we're going to be using this multiplication grid right here. It is a big box with 15 squares across and 15 squares down to make this big chart, this grid, okay? So we're going to look at a new tool that is going to help us to see our math in action. So instead of just solving equations and looking at numbers, we're actually going to build our equations. So today we're going to look at trying to solve some math problems that look like this. So we're going to look at things like 10 times 10, 11 times 13, 10 times 14, some problems like this, okay? So when we look at these problems, they look like they might be a little hard to do. They're not just one digit number by another one digit number. So we're moving into two-digit numbers now. So we're going to use this as a tool to help us see the math problem. So we're going to be using these grids to help us create arrays, and they're going to be able to show you how the multiplication works step by step. Right now, this just looks like a big box with some little squares on a grid. After today, this strategy is going to help you to understand not just how to find the product of two-digit numbers, but how and why it works. Okay, so let's dive in. So like I said, this is just 15 squares across by 15 squares down. So this is going to be our base. So for our first problem, we're going to start with 10 times 15. Okay, so that can maybe be a little scary to look at first. So let's see how we can visualize this, okay? So I'm gonna count, we're gonna take this first number right here, the 10. I'm gonna count 10 across this way, okay? So let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's our 10 across, and we're just gonna color that in. And then we're gonna take this number and we're gonna count that down this way. So here's 1 that's already colored in. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we're going to also color all of that in. Then we're just going to connect it and turn this into our array. And then we'll just color this in really quick. And it doesn't have to be perfect, just so you can see that something is starting to form here, right? All right, boys and girls, so I'm looking at our grid now, and I'm starting to see a shape. I wonder if we can maybe tell what this is. I'm gonna, in a minute, pass around some of these little shapes, and we're gonna look at these. So let me grab two really quick. So do you think this looks, what does this look more similar to? I think this one, right? So this multiplication problem is looking more like a rectangle right now. So that can kind of help us in the future. We're going to hold on to that. So our array right now for 10 times 15, it looks like a rectangle. And that's because multiplication is really just repeated addition. So when we're visualizing this, it just looks like 10 rows of 15. So when we repeat the same number over and over in rows, we can visually see this shape start to form, and this one happens to be a rectangle, and we're going to use this to help us find our total. So now there's a couple different ways we can go about trying to use this grid to help us find the answer or the product of this equation, right? So we could take our time and go through and count each square that we colored in, but that might take a while, right? So what we're going to do, and one way that actually works really well with this problem, is we're going to skip count. So we can count by tens. So we can go down this whole section right here. Each one of these rows is 10 across. We know that, right? Because there's 10 squares filled in this way. So if we skip count by tens all the way down to 15, that gives our answer. We can just go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150 is our answer. See, that's our product right there, okay? So we're gonna come back to this. This happened to work a little easy for this problem, but we'll come back to it in a minute when it can kind of get a little tricky. But I'll show you some tricks you can do. Okay, so that helped us to just not only find our answer, but we were able to see the multiplication visually on this grid. So now that we know that this is able to help us see things more clearly and actually be able to visualize our problem, I wonder if we could use this strategy to help us with even bigger numbers later on in our math journey. So let's just think about that again in the future. Let's try something different now. So we're going to try this equation. So our new problem is going to be 13 times 13. So now, what did we do last time, right? We counted 13 over this way. Well, it was 10 last time. Now we're going to count 13 this way, and we have another 13 going down. So let's do that really quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And I'm just going to outline it this time so we don't have to fill it all in. 1, remember we already counted 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So let's just outline this real quick. And I'm starting to see something here. I wonder what this means. So our last array looked more like a rectangle. This one is looking like a square. So we have exactly 13 squares across and 13 squares down. That means this is a perfect square. So when we see equations like 13 times 13 or 14 times 14, 15 times 15, any number times itself, any number multiplied by itself, that's going to be a perfect square, okay? So let's pause for a second. Does anybody know, or has anybody, let's with a show of hands, don't answer out loud, has anybody ever heard of the phrase perfect square before? A perfect square is when the number of squares across and the number of stacks in our array grid are going to be the same. So that means that the shape we're going to see on our grid is going to be a perfect square. It's not only just going to look like it, but it's going to be a perfect square all the way across. So this is going to happen when it's the same number multiplied by itself. So over here really quick, I'm going to show you what some examples of some perfect square problems look like. So if we're looking at some smaller ones like this, 5 times 5 is going to be 25. And these perfect squares, they can get a little easy for you to memorize. So when you see these, you can almost just see it and then remember next time, oh, I know 10 times 10 is 100. Oh, I know 5 times 5 is 25. And we can use that when looking at our grids to help us find the total when it's not a perfect square, because we can use that skip counting method. So let's try this out. So before we skip ahead, let's do the 13 times 13, right? So earlier, let me get a different color marker. We had 10 squares across in our grid, so that helped us to be able to easily skip count by 10. So let's see if maybe we can do that again. So if we count over here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and we kind of cut that off, we can skip count this section by 10 and then just add our remaining squares over here. So we know that this right here is 10 across, 10 across, 10 across. So we can do that same method. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130. So this section is 130. And then we can take these and then we can even skip count by 3. So like 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39. So now our new problem is going to be 130 plus 39, which gives us 1, 3, and a 3, 6, 169 is our answer now for that. Okay, so let's try one more. Now we've tried 10 times 15 and 13 times 13. So I wonder if we tried 11 times 14, would that be a square or a rectangle on our multiplication grid? Let's try that. So we're going to do 11 times 14. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So let's draw this out really quickly. So I'm thinking that this looks more like a rectangle. So this is not going to be a perfect square, because remember we said a perfect square is when it's one number multiplied by itself. So this is not 11 times 11 or 14 times 14, it's 11 times 14. So this is not going to be a perfect square. This is going to look like a rectangle on our grid. So like we did before, there's many ways we can count these tiles up to get our total or our product over here. So let's think about this again. So we have 11 across this time. So if we take, let me get another color. If we know this is 11, we can take one of these sections off. So we know that this is now 10 over here. So we can skip count again, okay? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140 over here. And then we know that going down, this is 14. So now it's 140 plus 14. And that's going to give us 154 as our answer over here. So boys and girls, I think we just covered a really great tool that we can use in the future when we have a math problem that we see and maybe we don't know how to tackle. So now we've seen how to build it, count it, and understand it, and we can use this in the future for our math problems.